In this video, we're going to talk about defining functions. Functions are usually just mathematical expressions or physical equations that you might want to use when plotting, integrating, taking a limit, or you might just want to evaluate them over and over again for specific values. So just like defining variables, this is an essential skill for knowing how to program in Mathematica. You can find functions in the following ways, okay? And I do make a note here, be careful with syntax. You have to use the exact syntax I'm showing you here, which means you must use square brackets and the underscore I'm about to show you. Okay, this first line, I'm just clearing these variables that I'm going to reuse. I don't really need to clear them. I can tell they are undefined because they're all blue in this notebook. But maybe I had another notebook open and I use the same variables, and I want to be sure I'm starting from scratch. Okay, here I'm defining my function g. G is the name of the function. It could be longer than one letter. It could be a whole word. Okay, I can name that just like a variable. I have square brackets here surrounding x underscore, and this tells me that g is a function that depends on a variable x. Okay, so it makes sense that x is the variable that shows up in the function. So I'm defining this function to be 2 times x. I can define functions that depend on more than one variable. Here I've got a function that depends on both x and y. Okay, so just using a comma to separate them. And now both of those variables appear in the expression. And I could use longer variable names, by the way, for x and y. I could put anything I want in there as long as it matches what I actually put in the expression. Okay, so if I run this cell, notice that these things are now defined, g and f. Okay, x and y are not defined yet because I haven't actually set those to a specific value. Okay, I can evaluate the functions by putting in numbers or variables, either defined or undefined, in for x and y. So here, this is saying, hey, just put in 2 everywhere there's an x, okay, because that's what my function is defined to depend on. Okay, and then this second line says, instead of putting 2 in, let's put in an undefined variable z everywhere. Okay, I can run that. Notice if I put 2 in, you get what you'd expect, which is 4. If I put z in, I just get a new expression, 2 times z, where z has replaced x. I might use this in a longer program. Say I've defined z at the top of the program could be equal to some value like 2. And now I don't have to remember that z is equal to 2 and put 2 in here. Maybe I'll make this 3 to make it more interesting. Okay, it will know that once I run this cell, z is equal to 3, and it'll put 3 in for z here. Okay, and then same thing for my function depending on more than one variable. I just have to put in the same number of things when I'm evaluating it, okay, as I define variables up here. So they can be numbers, they can be variables, they can be a mix. Okay, so let's see, I'll run this. Okay, I could put z in here. Okay. Function names can be cleared just like variable names. So here I've created perhaps a more meaningful function, the radius of, or the area of a circle, which depends on the radius, okay? So I can run this and I can evaluate it here for the radius being equal to 3, or my variable rad being equal to 3 here. Okay, notice the first time I ran it, it didn't know what rad was, so it just gave me this expression back. That's basically the right-hand side here. When I ran it, it gives me this back. That's symbolic notation. If I want to get that in terms of a number, I can do \n, and that will give me the numerical value instead. Okay, here I've cleared that function circle area. Okay, and in fact, maybe I'll do this in 2 cells so you can see this. Take this out here. Let's rerun that. Okay, notice again, if I use circle area, it goes and define it, it goes black just like a variable. Once I clear it, circle area goes blue everywhere. Now when I try, it gets undefined because I just cleared that variable or that function name. Now when I try to use it, Mathematica doesn't know what to do because it doesn't know a function circle area. So instead of giving me an error, it just outputs basically what I typed in, which is not the most clear thing Mathematica can do, but that's what it does. So if you're getting something back like that, it's probably because that particular function has not been defined, okay? And you probably wouldn't clear a function on accident like this, but one thing you might do on accident, if I run this again, is accidentally misspell a function name. So say you define this function circle area, and then you wanted to use it, but you accidentally misspelled it, right? Maybe I forgot the A. Okay, notice it's misspelled, which means I've really just have a new function name here that Mathematica doesn't have a definition for. So when I run it, I get this back out. Okay, that's an indication that I had a bug in there. I had a misspelled name. But another indication, of course, is that this is blue, which means it's undefined. So that's something to look out for when you're coding. All right, one more thing I wanted to talk about in this notebook is delayed variables and functions. Okay, so here, so far with variables and functions, we have been defining them with just equal signs here, okay? But there's a way to define both variables and functions in a way where you don't actually set the value or evaluate it right away, okay? And let me just give you some examples to help you understand that, okay? Here, I've used a built-in function, random real, to set r equal to a random number, okay? So it's a random number between 0 and 1. Okay, notice now if I call evaluate r, or print it out 3 different times, the value of r is set to what it was when I ran this up here, because I just used a regular equal sign. Now the value of r is fixed at that random number that was pulled up when I ran that built-in function, okay? If I use different notation and put a colon in front of the equal sign, this is called delayed notation in Mathematica. This means that it's actually not going to evaluate this line. It's just going to kind of put it in its memory. But every time I actually try to use r, whether just printing it out or using it in an expression, it's going to actually run this line. It's going to evaluate it every time. Okay, so let's see what that looks like. I run that. I don't get anything because it didn't evaluate it. It just kind of stored what it will evaluate in the future. And now if I run this line, notice that every time I print out r, it reevaluates this line and I get a different random number every time. It's very common to see this notation when you're dealing with functions, and let me show you why, okay? I want you to notice here this example, I have a function g, just like before, that depends on x, but now I've actually defined the value of x before I've defined my function, okay? So I'm gonna go ahead and run this, and I want you to notice what happens, okay? When I define my function here, because x has already been defined as a value 3, g is now set to be equal to 6, okay? It's no longer equal to 2 times x, it's equal to what 2 times x is equal to, which is 6. So when I try to evaluate this function later for different values of x, it doesn't work, right? Because it interpreted the right-hand side as 6 instead of 2 times x, because x was defined, okay? So a way to avoid this issue at really no cost, there's no disadvantage to doing this other than some computational time, is to declare what's called a delayed function. Okay, so just like up here, it's not going to actually evaluate this line. So let me show you that, what that looks like. It's not going to evaluate this line of code or basically set this particular value g in stone until I call it, and it will reevaluate every time I call it. So now when I run this, I don't get any output here, just like I didn't up here, because it really hasn't evaluated that line yet. And now when I use g, it works just like it did before, okay? It didn't set this equal to 6 now because it didn't really evaluate this function, and it's just going to plug in this value like it's being run from scratch for the first time. Okay, so when you're looking at examples, you'll often see delayed notation, and that is why.